Hello, good morning to everyone. And this is in front of you with your Charan, and I am pursuing 9th standard. So, friends, today I am your new maths teacher. So, today we are going to learn such a new concept where you're going to love this session. And definitely, I promise that you will enjoy this session. So, shall we start? And here we go. So, today we are going to learn a new topic which is from mathematics subject, and the topic is degrees in polynomial. Right. So, then let's start our class. So friends, here. So then what are the learning outcomes? See, after listening my lecture, what are the learning outcomes and what are you gonna learn from my lecture? See, what you're gonna learn after this, what you will gain the knowledge from my topic. And you will get a better clarity about the word polynomial and understanding the concepts of variables, constants, grasping the knowledge of degree of the polynomial, and finally you will make a grip of types of polynomials which is based on degrees, right? See, these are the learning outcomes of this topic. So then still we start here. So from earlier to still now we are learning about algebraic expressions. As our classes increase on going on, so now we are learning about polynomials. So what is meant by the word polynomials? Such a new type of word. And here is the definition for that polynomials are. Polynomials are defined as an expression that has variables, constant terms, and coefficients with non-integral powers. See, this definition is such what difficult to understand, right? So to make it easier, let's look at a story. So if suppose we all are went to a supermarket and we are supposed to buy our home needs. We are supposed to buy our home needs. So I buy 1 dozen eggs, means 12 eggs, and 2 kg dal and 1 kg flour. So to need to get this total amount, we need to calculate the final result of each item, right? See, for example, I need to multiply my 12 eggs into each cost, means the cost of each egg. So here the E represents the cost of each egg. So 12 is multiplied by E. So to get this total amount of my eggs, so then 2 kg dal is multiplied by cost of 1 kg dal to get the final result of this dal. So then 1 kg flour is multiplied by 1 kg flour to get this total amount. After getting this all final results, we need to make a total cost. And here that is total cost, which is equals to 12E plus 2D plus 1M. So this makes an expression, right? So this makes such a new expression, and that is called as a polynomial. And that is called as a polynomial. And he can, so now we can observe here we have variables, constants, as well as what terms, coefficients with non-integral powers. So then what all are these new words? Variables, constants, such a huge big of. So it's not at all problem. Let's learn about them. So first of all, variables and constants. When we talk about the word polynomial, the main two things which arises in our mind that are variables, constants. So they are such easy and simple to understand. Here, a variable, the value which varies. In the sentence, it says that the value which varies means the value is not at all fixed, means the value will be changed. Either it may be continuously or simultaneously, but the value will be changed, right? So then what is a constant? So it is whereas constants are opposite to these variables, the value that cannot change means it is a fixed value that cannot change. So to need to get better clarity, so here look at this example. So then, so how many days are there in January month? So let's talk about this year. In 2021, we have 31 days. So when you observe for every year forever, there will be 31 days in January. It is fixed. You observe, once you observe in all calendars, 31 days of fixed for January month. So here, the days in the January month are constant. The value that cannot be changed, and it is a fixed value. And next, where you can observe the population of India. So is it fixed value? Is it fixed value that population of India? No, not at all fixed. But because See, for every year it may be increase or decrease, but due to in this pandemic situation, we are observing due to many reasons, the population of India is decreasing. Not only India, many other countries. So here the population of India is a variable, the value which varies, the value which is not at all fixed. And here you are looking pizzas. I love to pizzas. I love to eat that pizzas. Are you? Yes. So these pizzas, see the cost of mini pizza. For example, the cost of mini pizza is 80 rupees for this month. So then what about for next month? See, it is not fixed. Why? Because see, which is based on either it may be production or in what income of this owner. He can improve the rate or he can decrease. Means he can increase the rate or he can decrease. We don't know. So that's why the cost of mini pizza is a variable that cannot change. But the quantity of mini pizza, for example, see the half kg mini pizza weights. The quantity of mini pizza means the mini pizza weights half kg. So then it is fixed for all mini pizzas. Am I right? Yes. So see here, I am not listening, means I am not explaining about the lecture. You are not listening the lecture. Just we are discussing how to make a food item. Yes, here food item is polynomial. So to know to make that food item, we need ingredients. So then what are ingredients? Variables, constants, coefficient terms, and as well as so and so non-integral power. These all are what? Ingredients. So to make food item polynomial, we need to do what we need to do. We need to add all of these ingredients. So then, so why we are learning about all of this? Because to need to identify ingredient, first of all, we need to know about that ingredient, right? First of all, we need to know about that ingredient, that how it looks like, right? We need to know about that ingredient, how it looks like, how it will be. So for that, we are learning about this. Then, what is meant by this coefficient sign terms? Right, a number which is used to multiply with a variable. A number which is used to multiply, a number which wants to multiply, a number which is liking to multiply with a variable, and hence it is called as a coefficient of that variable. Here we had 8x square minus 5x plus 6. So here 8 and minus 5 are supposed to multiply with the variable x. So hence they are called as coefficients of variable x. So what is the coefficient of x square in this given polynomial? 8. What is the coefficient of x in this given polynomial? Minus 5. That's all. So then what is meant by terms? A single mathematical expression. What it is? A single mathematical expression. Right. So here we mentioned that term 1, term 2, term 3. A single mathematical expression, 8x square is one expression. So if any operators like plus or minus are included in two terms, so then it will become two terms, right? So it's about this, a single mathematical expression. So then see, now we made food item. We all know about ingredients, right? So now let's cook it. Mix all of this. We get a food item. What is it? A polynomial. So, but not at all making one food item. We need to make many of the varieties, right? So to need to make that many of the varieties, what we need to do? So we need to make many of the varieties from that food item. And here that is the classification of polynomials, the types of polynomials, and it is classified based on two words. What are they? Which is based on term, which is based on degree. And one more new word arises, what is meant by degree. Degree means we are not discussing about after intermediate degree. In maths, it is different. So let's look at them. So to need to identify a given polynomial, whether it is a polynomial which is based on degree, whether it is a polynomial which is based on term. So we need to identify, right? So for that, we need to learn about the general form of a polynomial, which is based on what? Degree. So in this lecture, we are going to learn about the general form of a degree, right? And here, what it says, so P of x means the polynomial with a variable x. P of x means the polynomial variable x. That is an x to the power n plus an minus 1 x to the power n minus 1 plus an minus 2 x to the power n minus 2 plus, as it is goes on, and a1 x to the power 1 plus a to the power 0, which is constant. Remember that constant, the power of the constant is always 0, right? So here we can say that directly an minus 1, an minus 2, a1 are what? Coefficients. So these all are supposed to multiply with a variable called x. So what is the coefficients of x to the power n minus 2? An minus 2. So then what is the coefficient of x to the power n minus 1? An minus 1, right? So these are what variables which are supposed to means the variables which are multiplied by this coefficients. So here we can observe that especially they given n as a degree. But why? Why they given n as a degree? Right? For let's suppose, for your assumption, let's keep 9 in the place of n. Whatever the it may be value, but we need to not take negative. What is negative? Do not take the negative ones, because we know that the polynomials are made up of positive powers. Remember that. So polynomials are made with non-integral powers, means non-negative powers, and which are positive one. So here let's put only positive. If we put negative, it's totally entire form will become not a polynomial. Let's put 9 in the place of n. So what happens? So going to the next term, n minus 1 means 9 minus 1, which becomes 8. X to the power n minus 1, which becomes x to the power 8. From here, from next term, when we go to the next term, it becomes 7, 6, 5, 4, 3, 2, 1, and lastly 0. So here what we can say that a polynomial which is based on degree, so when it goes on, the degree will be decreasing, right? So means the powers are decreasing, right? So here when the powers are decreasing, so we can directly say that the first term, the power of the first term of given variable in a such polynomial will become our degree. The highest power of the given variable in a polynomial is the degree of that polynomial. So here n is the degree, we can directly say. Why? Because if you go right hand side, it is increasing or decreasing? It is decreasing. When it is decreasing, we can directly say that n is our degree. Why? Because it is the highest power, right? So this is what the degree. The highest power of a given variable is a polynomial. In a polynomial is the degree of the polynomial, right? So then, are you getting bored? So let's keep this subject a part of side. So let's keep this subject a part of side. Now let's discuss in general what is meant by degree. So in many of the schools, they will be given degree certificate in many of the schools. So means most of the higher schools, right, which are well defined. So in that schools, they will be given as a level 1, they will be given the degree certificate as a level 1. So in college, they will be given degree certificate as a level 2. But in graduation, after completion of graduation, they will be given what as a level 3, they will be given the degree certificate. So based on these levels, it is divided. Based on the student's mentality, his performance, it is divided to make that given degree certificate. See, as like this degree, our in mathematics, the polynomials are divided. Means we had a types of polynomials based on degree, and they are, if the given polynomial is having degree 1, it is called as something. If the given polynomial is having degree 2, it is called as something. What all are these something, something, something without doing something? Let's learn something to make it perfect. So polynomials. So linear polynomial, right? So then, if the given polynomial is having degree 1, then it becomes our linear. In the word itself says that linear, which is having degree 1, right? And here, remember that if the given polynomial is having degree 1, it is called as a linear polynomial. And here there's a general form that ax plus b, where a should be not equal to 0. A should be not equals to 0. So then coming to the point of, so once observe the pictures which are there beside of this table. So we had line. So what are the dimensions of line? Only one dimension, that is length. So length, see, as like this, the linear polynomial will have only 1 degree. So then it is called as linear. So once of the second image, rectangle. So what are the dimensions of rectangle? It is a 2D shape. So it has two dimensions. One is length and another one is breadth. See, as like this rectangle, the quadratic polynomial means if the given polynomial is having degree 2, then it is called as quadratic polynomial. The degree means the polynomial with the degree 2 is called as what? Quadratic polynomial. See, we need to identify individually for every term. You need to get this total. So after getting final, you need to compare. See, the first term exponent is greater than or less than with another one, right? So quadratic, so polynomial with degree 2. And here we had ax square plus b plus c, where a should be not equal to 0. Coming into the point of third image, cuboid, having 3 dimension, and hence it is called as 3D shape. We had cubic polynomial. So cubic polynomial means if the given polynomial is having degree 3, then it is called as cubic polynomial, right? So here p of x, which is equals to polynomial with a variable x to the power 3 plus bx square plus cx, where a should be not equal to 0. So what can you say from this table? In each and every case, I have written that a should be not equals to 0. But why? But why a should be not equals to 0? What happens if a is equal to 0? What happens if b and c are equal to 0? What happens if b and c are not equal to 0? Let's look at it. So in first case, let's look at about first case. See, let's put for your assumption, let's put a equals to 0, right? For your assumption. So when you put a equals to 0, so total first term means the entire first term will become totally 0. Why? Because 0 into something means 0 into x will become 0. We left with only constant, that is b. We left with only constant, that is b. So if we left with only one constant, that is b, so we already know that the power of this constant is 0. The power of the constant is 0. So when the power of the constant is 0, it will not at all become a linear. It will become what? 0 polynomial. So if the given constant is having power 0, means we will only consider the degree of the variables, right? So for that, we need to multiply a variable with x to the power 0 with constant. It becomes 0 polynomial, right? So how we need to identify variables, right? So lowercase alphabets x, y, z for variables, we know that. And for constants, we use real numbers and as well as alphabets for constant to identify, right? So coming into the point of second case, see here what we said that if the total term will become 0, we left with only constant. That constant will be not at all become linear. So that's why a should be not equal to 0. So then what happens? See here only they mentioned a should be not equal to 0. But if b and c are is not equal to 0, if b and c are equals to 0, let's see. If in second quadratic equation, a to the power ax square plus b plus c, right? So then a is not equals to 0. So let's put b and c are equals to 0. If b and c are equals to 0, what happens? Even the b and c are equals to 0, let's put b and c are equals to 0. So then we left with only one term, that is ax square. Even the b and c are equals to 0, that one term is making a quadratic. Yes or no? Am I right? Yes. Even though b and c are equals to 0, we left with only ax square. So that term is making quadratic polynomial. So in second case also, put b and c equals to 0. What happens? So these two terms, second term and third term will becomes our 0. Becomes our 0, right? So if it becomes our 0, we left with only one term, that is ax cube. So ax cube also making cubic polynomial. See, if we put b and c are equals to 0, it is not at all problem. It's nothing will be happen if we put or not put, right? If we include or not include B and C are equal to 0 is not at all problem. But what? A should be not at all equal to 0. Why? Because it will not become that if we cubic. So for example, cubic, if you put A equals to 0, this entire will become quadratic. It is jumping upward, right? So that's why the given polynomial, when the given polynomial, you should mention that A should be not equals to 0, right? So then, how we need to identify? We all know that. So then, maximum terms. If the how many terms should be a linear polynomial should have? A polynomial with degree 1 means what? Linear polynomial. X plus 8. So x, the power of the x is 1 and the power of the constant is 0. We have only one, that is linear one. What are maximum terms? 2. So here maximum terms 2 means, so it can be 2, it can be 1, but it cannot be 0. But it can also, means it cannot be also cross 0. Maximum terms 2 means it cannot be 0 and it cannot be cross 2, right? So it can be 2 and below of 2. Coming to the point of quadratic equation, 3x square minus 4x plus 7, we had maximum terms 3 here, but we can also include maximum terms, means maximum it should be 3, but it can be also 2, it can be also 1, right? In next one, cubic polynomial, if the maximum terms are 4, it can be 3, 2, 1, right? So when you put 0 in the form of constant in quadratic polynomial, we left with only 2 terms. If you put 0 in the form of second term, 4x will become 0, we left with only 1 term. Also it becomes quadratic, right? So even though if it is becomes A is not equals to 0, it becomes a polynomial. When A is equals to 0, it becomes what? It becomes polynomial, but it will not at all becomes a quadratic. So the maximum terms of these polynomials and types of polynomials are these. So for linear polynomial, the maximum term should be 2. For quadratic polynomial, the maximum term should be 3. For cubic polynomial, the maximum term should be 4. Right? So then, why we need to learn all of this? Finally, we are on conclusion. I am giving lecture for you. You are listening, but why? Why what? But for what we are learning, right? For what we need to learn all this, right? Why we need to learn? Why you need to listen? Why I need to tell? Because these such polynomials are used in more complex calculations in our daily life. It is very, very important to learn these polynomials in our daily life. So these are useful in our daily life situations in many aspects, right? So what are those all? So before going to learn about the daily life situations, we need to remember one thing. Are we forgetting? No, it's an important one. Here, what it states, the maximum possible numbers of terms in a polynomial is 1 more than its degree, right? Are you understanding? If the maximum possible numbers of a terms in a polynomial are 1 more than its degree, means if the terms are 4, the degree will be what? 3. If the terms are 5, the degree will be 4. Means if the degree is something, so the terms will be 1 more. If the degree is 1, the terms will be 2. If the degree is 3, the terms will be 4. If the degree is something, then the terms will be 1 more than its degree. Right? For example, let's look here. So here 8x square minus 5x plus 6. So here, what is the degree of the given polynomial? 2. Degree is 2, right? So then what we learned, the terms will be 1 more than its degree, right? So if the terms are 2, if the degree is 2, so then what are the terms? 3, right? 1 more than we learned. So that's what I want to say from here, that if the maximum possible number of terms in a given polynomial is 1 more than its degree, right? So just now we discussed why need to learn polynomials. Why? Because in many fields, see in economics, or used these polynomials to model, means to memorize the economic in a year, in a model pattern. And also medical researchers are using these polynomials to determine the bacterial colonies, how the bacteria in this situation, mainly COVID-19, how it is spreading, right? So in a graph, in a such graph, see here you are seeing the graph. So in such this graph, how it is increasing in one country, how it is decreasing. So this all, right? Polynomials are used in many such complex. Even a taxi driver is benefit from this polynomials. Yes, even a taxi driver is benefit from polynomials. How? Because suppose a taxi driver wants to know how much miles he should travel to cover, means to get $100. How much miles he should travel to get $50. You need to calculate that, right? So these polynomials are used in our daily life in different situations and also in other subjects. See the great equation given by the Albert Einstein in physics. What is it? E equals to mc square, right? And the second, Newton's laws of motion states that what force is directly proportional to the mass and acceleration. Means F is equals to ma. And the three equations of motion in physics. What are they? V equal to U plus 80, S equal to UT plus of 80 square, V square minus U square equal to 2AS. See, these all are what? These all are polynomials which are used in what? In the physics subject. So not only including the physics subject, we had many of them which are useful in our life. Right? Here one more. So this can be also used in chemistry. Right? So to need to make the chemical formulas, we use crisscross method as like this. We use crisscross method. So when you observe here, it is same as like in the form of general form. When you apply, means when you're making the chemical formulas by crisscross method, so whatever you are getting the final result, it will absolutely looks like a general form of this polynomial, which is based on degree. Once try, once you try it, you go ahead. So these are the polynomials which are used in our daily life. So these are very, very important to learn, right? So now you are not wasting time by listening my lecture. You are gaining something. You are gaining something in our daily life. You need to survive our life, right? So then, so this is all about our class. So now we are on conclude. So then assignment for this lecture is find the degree of the polynomial. Find the degree of the polynomial means find the degree of the polynomial of given polynomials and identify the type of polynomial. Right. So here I have given you some of the polynomials. You need to identify whether it is what type of polynomial. So you need to find the degree of that polynomial, right? So these all about the degree of that polynomial. See if the given polynomial is having something what 119 number. If the given polynomial is having degree 119, 119. So what do we call? Anything if that has anything if that has infinite number means let's put n. If the degree of the given polynomial is having n, equal is it equal it has n the degree of the polynomial. 119 means 119 the degree of the polynomial. That's all. Next question. How do you think that these polynomials are used in various situations? Right. So these polynomials are used in various situations, right? How do you think that? How they will be helpful to people? So think of it and let's memorize this assignment. So now this is concluded. So what I want to say for this lecture is this. So let's see some of the questions from audience. Anand.
Okay, thank you, Charan. So I would like to ask you, you were talking about the types of polynomials based on degrees. So what is a polynomial with a degree with degree 4?
Ma'am, can you repeat it?
So you were talking about, can you hear me?
Yes, ma'am.
you were talking about types of polynomials based on degree.
Yes,
Okay,
ma'am.
and you explained three of the three types. So,
Yes.
what is the degree of 4?
Yeah, ma'am. Good question. So, what is the degree of 4? It's an interesting question that, see, here we learned that 4 is a constant. So, we already know that the power of the constant is 0, but we will consider only the degree of variables. But here nothing is there variable, right? So, for that, we will multiply x to the power 0 for this constant. Means 4 multiplied by x to the power 0. So, now we can say that here given polynomial is 4x to the power 0. So then degree of that polynomial is what? 0. Yes, ma'am. So the degree of given polynomial 4x to the power 0 is 0, ma'am. Yeah, can we hear next question?
Okay, so I would like to ask you, can you tell us some of the major fields where polynomials are like used?
Yes, ma'am. Thank you. It's an relevant question that can you say what fields. So in different fields we can use. So in various situations we can apply these polynomials, right? See, just now we have discussed medical researchers, but the chemists means the chemical researchers will determine means how much the chemical compounds will added in a molecule in a certain temperature in a certain what climate change. So the chemist will determine the given what compound, the given chemical fertilizers. So to determine that they will add what molecules, atoms, so some of the chemicals, right? So how they need to add? So in such quantity, right? So they randomly they will not mix. So they need to get a what such type of quantity to add that. So for that they will use these polynomials. And what many of these scientists and researchers, mainly the researchers, will use the graphs of polynomials to make research on. And can you hear next question?
Okay, thank you, Charan. Can you also explain the effects of positive and negative degrees on the polynomial expressions here?
Yeah,
For example, using some graphs or something.
yeah, good question, ma'am. So here the positive and negative, but you know that. So if the given polynomial is having degree negative, it will becomes not at all polynomial. So that's why let's talk about this what positive one. So if the positive, the effects of positive on graphs. So the parabola will depends upon the nature of A. A means the coefficients of the given what given polynomial. For example, here 7x power 4. So here 7 is the A, means it is the coefficients of x to the power 4. So when A is greater than 0, so then parabola is drawn like upward. When A is less than 0, then parabola is drawn downwards. Right? So it is depends upon what the nature of A. So these are the effects how the parabola is drawn on the graphs using these various types of polynomials. Yeah, ma'am. Can we hear next question?
Thank you, Charan. We are done.
Yeah. So this what I want to conclude, and I convey my sincere thanks to everybody, and especially Secretary Sir and also ma'am and mentor teacher Sridev ma'am and my guidance Matt sir and everybody who supported me a lot for making this great presentation on this great platform. Thank you, one and all.